So a viewer today sent me this question, and we're just going to have a look at how this works, okay? So the question is question 6 and specifically 6e, right? So this question is saying for each of the following angles, state the other angle between minus 180 and 180 that gives the same values for sine and cos, okay? So if we think back to the unit circle, right? So I'm just going to switch the tab here. If we think back to the unit circle, right, this is what we see, okay? So as we have different values for theta, right, on the unit circle, we trace out, for example, right, if theta was this particular value, we're going to have a triangle, right? And what you see here is the blue dotted lines. These represent the height of the triangle, and the red dotted lines represent the base, okay? So as we see from the start, as we go higher, the red dots gets higher, and the blue dots get shorter, okay? So as we know, the red dots represent sine, and sorry, the blue dots represent sine, and the red dots represent cos. Okay. Now let's see what happens when we move past 90 degrees, right? When theta gets greater than 90 degrees. Let's see what happens. Okay. So when theta gets past 90 degrees, right? What's going to happen is the blue dot, right? They are still on the top, but the red dots are going to come to the left, right? Before they were on the right, but past 90 degrees, they'll be start to encroach on the left. Okay. So when we calculate cos and sine using the unit circle, the direction of the base also matters. Okay. So for example, right here, cos theta will be probably a half, whereas here, cos theta will be minus a half. Okay. But what you see is between these two quadrants, right? The first quadrant, second, third, and fourth. So starting from the first quadrant, between the four quadrants, the first quadrant and the second quadrant all have the blue dotted lines going up, right? It's all above the x-axis. So that's telling us that sine theta is positive for first and second quadrants, okay? And why is that important? Let's go back to our whiteboard. Okay, so back on the whiteboard, right? Let's have a look at these two values, okay? So on the left here, we have, let's say this is probably 30 degrees. On the right, so if this is 30 degrees, then this bigger angle here is going to be 150. Okay, so just something that I haven't mentioned before. When you count the angles on the unit circle, you would count anti-clockwise. Okay, so you're counting in this direction, right? So this is 150. But if we look at the actual triangle that's being formed here, this triangle here, the internal angle is, well, it's going to be 30 degrees as well, right? Okay. So what we see now is this here, this is going to be sine 30, and this will be sine 150, okay? And if you just have a look here, these two triangles would have the same height, okay? Because they're pretty much mirrored images of each other from the first quadrant to the second quadrant. And because these are both pointing up, we can confidently say that sine 30 degrees is going to be the same as sine 150 degrees, okay? So let's just think about another example. So let's go down to here. Okay, we'll draw another unit circle. Let's use the drawing. Now here, let's say we've got an angle at this point here. Right, so this is the angle theta. Right, and the corresponding triangle we're going to draw would be this one. Okay, so that's sine, and this will be cos on the base. Okay, so for this triangle, if we want to find the other angle, which gives us the same height, we would come to the second quadrant, right? Why the second quadrant? Because here we see that the height is positive, it's going up. So we want to find the other place where the height is going up, right? So that's going to be the second quadrant. And what we're going to do is we're going to look for an angle right? Such that this internal angle is, like I said, a mirror image of the first quadrant, right? So these are mirrored images, okay? So of course, this is sine theta, right? And then this bit here, if you think about the supplementary angles, this here is going to be 180 minus theta, right? So what we have is sine theta, this one here, is equal to sine of 180 minus theta. Okay, so this is the rule that you've been sort of taught at school. All right, cool. Now, let's go back to the question, right? So the question here says, for which angle does it give you the same value as minus 15 degrees? Okay, so let's rub this out and figure out where minus 15 degrees would be. Okay, so let's just draw another unit circle here. Unit circle. Okay, so let's see what the question puts us at, right? So this is minus 15 degrees. Remember, positive angles, right? They go anti-clockwise. So if we have minus 15, we have to go clockwise, right? So this is clockwise 15 degrees, right? But this really, so the internal angle is 15, but really the angle here is minus 15 degrees because it's going in the opposite direction. Okay, so of course, let's draw the height as well. This is going to be our value for sine theta, and this is here is going to be our value for cos theta. Now, let's see. So this is our value here, right? And as you can see, we're in the fourth quadrant, and the height is going down, right? It's going um, down towards the fourth quadrant, whereas before the height was going up. Okay. So if the height is going down, that means the value is going to be negative. So straight up, we know that sine of minus 15 is going to be negative. Okay. Now let's think about where else can we find this height, right? This particular height. Well, we know that for the first and second quadrants, right? So for the first and second quadrants, so the height is always pointing up, right? Sine is always positive. So the only option we have is the third quadrant here, right? So let's see what that's going to look like. So that's going to be like this, okay? And what do you see? We have the same height, okay? The same height, and it's also pointing down, okay? Also going down. So this is what we have here in the third quadrant is going to be the mirror image of the fourth quadrant, right? So if it's mirrored, then whatever we have here, which is 15, is going to be 15 here as well. Okay, very nice. Now, here's the question, right? What is this angle? Right, what is this angle here? Because this, to count the angle on the unit circle, we always start with the positive x-axis. In other words, we always start from here, right? So what is this angle here? Let's figure that out, okay? So using the supplementary angle, right? We know that here has to be 180 minus 15, which is 165 degrees. That's going to be the size of this angle, right? But also remember that we're going clockwise, right? We're going clockwise to reach this angle here. And on a unit circle, clockwise is always negative. So this is going to be minus 165 degrees. Okay? And for what the question has given us, right? This one here would also be minus 15 degrees. I just didn't put it there. Okay? Again, because to reach this angle or to reach this triangle here, we have to go clockwise from the positive x-axis. Okay? So just once again, the positive x-axis would be this line here. Okay, so it's sort of like bearings if you've done bearings. All right, so that's the answer for sine. So sine of minus 15 degrees is going to be the same as sine of minus 165 degrees. Now, let's use the same rule for cos, okay? So let's look at cos. We're going to be in the same position, Right, so again, let's draw a unit circle. Okay, we're going to be in the same position, minus 15 degrees. Okay. So again, remember, the sine is the height and the cos is the base, right? So cos is going to be here. This is going to be cos. It's going to be whatever this height is. Sorry, whatever this length is, right? So again, let's think about which quadrants are going to give us this length, okay? On the unit circle, the left is negative and the right is positive. Okay, so it's just like um, the Cartesian plane, right? So right is positive x and left is negative x. Okay, so because this base here is going to the right, its value will be positive. So straight up again, we know that cos minus 15 is going to be positive, right? So we can't have anything on these two quadrants. Why? Because anything here would require the base to be going to the left, right? Going to the left. And if you've got an angle in this location, again, right, when we form the triangle, the base is going to the left. Okay, we can't have that because here our base is on the right. So the only place where we can have that is going to be the first quadrant, right? So let's see where on the first quadrant. So we know it has to be here, right? So it has to be something like this. So it's going to go up, right? And this is going to be our triangle, right? Again, this is a mirror reflection, right? Before we had a mirror reflection vertically, this is a mirror reflection horizontally, right? And the purpose of that is so that they share the same base. Okay, here they share the same base. So the angle here is going to be, well, let's think about it, right? We're starting from the right, the positive x-axis, and we're going up. When we go up, that's counterclockwise, right? So counterclockwise, mirror image, so this is going to be 15 degrees, okay? Same angle, except this is positive. So what do we know? Cos of minus 15 degrees is going to be the same as cos 15 degrees. Okay. And that's the answer for this question. All right. So feel free to use the same method to have a go at the other questions. The process will be the same. Just remember, when you go clockwise, so when the angle goes clockwise, it's going to be negative. When the angle goes counterclockwise, it's going to be positive. All right. So that's all we have for the video today. Thank you very much for watching, guys. I'll see you next time.